All right, I'm your man, John Wilson. We got a good one for you today. We're going to finish up Module 2, 2.4. We're going to learn how to add, subtract, multiply, and divide using scientific notation. And then we're going to define calculator notation, and we're going to learn how to convert to and from this numeric form.
Wow.
Before we even get started, though, we need to go back to Module 2.2 and 2.3. We need to make sure that you understand the rules and the parts of scientific notation and the rules for multiplying and dividing powers with like bases. So let's go through the parts of scientific notation, because this is very big at this point on the vocab. I need to make sure you understand the vocab. If I asked you what a coefficient is, you're going to need to know that a coefficient would be this number right here. And a coefficient, let's just make sure we remember, coefficient must be greater than or equal to 1, and it must be less than 10. Are we all writing in? Some people just staring at their pencils like, why does this thing work? All right, so coefficient, that's the first part. What comes next? What's this? Multiplication sign. That's division. No, multiplication sign. And this, what's the proper term for this? This is the base. And then the very last part, this is known as the exponent. And if you remember from modules 2.2 and 2.3, the exponent can be positive. It can also be negative. That's very important to watch out for. So this was 2.2 and 2.3. We also revisit the rules from 2.1. If you remember, when we multiply powers with like bases, what do we do with the exponents? We add the exponents. We would do something just like this. Let's say that we have 10 to the third times 10 to the fourth. What am I going to do with those exponents, Viviana? We're going to add them. So it's going to be 10, and what am I adding together? 3 and 4. It'd be 3 plus 4 is equal to 10 to the 7th. That's important. We're going to be multiplying with scientific notation today, and when we get to the bases and the exponents, that's what we're going to be doing. And let's look at cart left. Drew. When we divide powers with like bases, we blank the exponents. What do? We subtract the exponents. So if we're dividing like bases with the powers, we subtract the exponents. It's going to look something just like this. We have 10 to the, let's make this interesting. 10 to the third over 10 to the fifth. Why not? What am I going to subtract, Drew? 3 and a 5. So we're going to do 10. 3 minus 5. What's that going to give me? What's 3 minus 5? Think about it. You can use counters. All right, we can use counters. So what number is this? Positive or negative? Positive. So let's write 1, 2, 3. Positive, right? Just real quick to make sure we have the right number. What number is this? Negative 5. 1, 2, 3, 4, 5. If we have a positive and a negative, they will cancel out. Cancel, cancel, cancel. What do we have left? Negative 2. So this becomes 10 to the negative 2. Can you ever leave a base with a negative exponent?
No.
No. So, let me erase this now just so I have space. Drew, what are you going to do to this? Okay, tell me, what is my fraction going to be? 1 over 10, and the exponent's going to be? It's going to be 2. Yeah, it becomes positive now. And if I had you evaluate this, it would be 1 over 10 times 10, which would be 1 over 100. Just make sure we remember how to do all that stuff. Yes, sir. Okay, now moving into multiplication with scientific notation. It's some simple steps, but what I'm going to need you to do is 2 things. 1, don't ever use a calculator when you're doing this. You're not allowed to. 2, you need to remember how to multiply with decimals. You'll also need to remember how to divide, add, and subtract with decimals. Should you forget, I have uploaded videos to the homework already that will give you a quick refresher on multiplying, dividing, adding, or subtracting. That's all from 6th or 7th grade. If you still understand, come and see me. All right, because by now, and this level, we should know how to multiply or divide, add or subtract. If you forget, let me know and I'll slow it down and I'll show you how to do it. When we multiply with scientific notation, first thing you do is you're going to multiply your coefficients. What are my coefficients here, Emily? What are my coefficients here? I have 2 of them. What are they?
2.4 and 1.5.
2.4 and 1.5. We're going to take these and we are going to multiply my coefficients. I'm going to do 2.4 times 1.5. In the interest of time, I'll do the multiplication for you. This is going to equal 3.6. So my coefficient, done. Now I have to look to the exponents. When I have two parentheses together, what operation is that? Anybody? Anybody, what is it? Just anybody. Multiplication. So I'm multiplying like bases. You see that? A 10 and a 10? What am I doing with the exponents? I'm adding them. It's going to be 10. 3 plus 4, which is going to give me 10 to the 7. So I multiply the coefficients. I have my exponents. And the last thing is to write out your answer in full and correct scientific notation. Before you do that, though, you need to take a look at your coefficient. Is this a good coefficient?
Yes.
Yes, because it is greater than or equal to 1 and it is less than 10. Matthew, question.
Can't wait for all that.
What, the next one?
Yeah.
If I
No, not next one.
You want to write it? Oh, you want to write it out? All right. Okay.
But you're not allowed to show his face.
What you got?
Well, 3.6.
3.6.
With the x.
The times.
Or times. And then 10.
10.
And then to the 7th power.
To the 7th power. And that's it. That's your answer. It's just that simple. The only thing that you really need to remember is how to do this. Do not use a calculator with your homework. You're not going to be able to use it on a test or your FSA when it comes to these types of questions. Do it pencil and paper. Should you forget, come see me, or just look at one of the videos I put up on multiplying, adding, subtracting, dividing with decimals. You know, click back. Hey, I remember that from 6th or 7th grade, or 6th grade, whatever works for you. First one done. Emily, you take it. Count go! Calco. Right there. And you too. Calco, what am I doing first, man?
You have to multiply the two coefficients.
Okay, I got to multiply my two coefficients. What are my two coefficients?
5.4 and 2.5.
5.4 and 2.5. We're going to multiply 5.4 times 2.5. And you know what that is? All right, well, I'll do it for you in the interest of time. When you multiply this out, 5.4 times 2 would be 10.8. And then you have to do 5.4 times 0.5, that would be 2.7. If you put all of that together, 10.8 and 2.7, you will get 13.5. So I multiplied my coefficients. Now, what do I do with my bases?
You have to add them.
I have to add the what?
The exponents.
Add the exponents. And I'm going to have 10. And what are my exponents?
10 to the 5th power plus 10 to the 6th power.
Good, yeah. When we multiply like bases, we add the exponents. And what is that going to give me?
10 to 11.
10 to the 11. Put my whole answer together for me, man. What am I going to write? Right here. 13.5 times 10 to the 11. And then you would just drop the mic and you walk away, right? That would be your answer?
No.
No. What's wrong with it, Shimon? What's wrong? Anybody want to help him out with what's wrong? Miss Bolaños, what's wrong?
The coefficient is bigger than 10.
Coefficient's bigger than 10. Can't have it. Got to do something with it. I need to shrink this down just a little bit. So, Sydney, I'm coming around to give you a ticket. Sydney, what do I got to do here?
You have to put the 10 instead of 11 to 12 because you're moving the decimal.
Okay, well, let's move the decimal first. Which way do we have to move the decimal?
To the left.
To the left, how many times?
1.
Once. I move the decimal once, I drop it there. This is going to become 1.35. Inverse relationship. Coefficient got smaller, exponent gets bigger. I move the decimal once, so what am I going to add to 11?
12.
1, not 12. I'm going to add 1. Yes, it'll become 12. Plus 1, and this is going to be 1.35 times 10 to the 12th power. Always make sure that your final answer is in correct scientific notation. Any questions on what we did here? Questions? Answers? Questions? All right.
Yeah.
Okay, those whiteboards are over. All right, so now we're moving into division with scientific notation. And division with scientific notation uses the same rules that we've already learned. When we have like bases, what do I do with the exponents?
Subtract.
I subtract them. When I'm dividing and I have like bases, I subtract the exponents. Yeah, the exponents. But before we even get there, we have to deal with the coefficients. Now, obviously, this is division, so it's pretty straightforward. You're going to divide your coefficients. You're going to do 9.6 divided by 2.4. Anybody know what that is off the top of their head? It's a whole number. Yeah, you're right. It's 4. 9.6 divided by 2.4 is 4. So we divide our coefficients. Once we divide our coefficients, then we look. Do we have like bases, yes or no?
Yes.
Of course. In the scientific notation, the base is always going to be 10. So what, Miss Vega, what am I doing with those exponents? Subtract them. So I'm going to do 10. What's my exponents? No, tell me, what are the exponents that I have here? 5 and 2. Yeah, you already did the subtraction, but we're going to write it out for every 5 minus 2 gives me 10 to the third power. Okay, good. And then, once we have our coefficient, once we have our exponent, we look, is that a good coefficient, yes or no?
Yes.
Yes, so we simply write it out in scientific notation. Sine Cassidy, what is going to be our answer in good scientific notation? 4 times 10
to the third power.
to the third power. 4 times 10 to the third. I double check my coefficient. It's greater than or equal to 1. It's less than 10. Good job. Good job. Good job. All right, let's go to Rachel. Rachel Thomas is right over there. Rachel. Okay. What are we doing? You tell me. Divide the coefficients. What are my coefficients? 2. You can do 2 divided by 5. Do you know what that is? Well, 2 divided by 5 is not going to be 2. Let me show you how we do this. 2 divided by 5, right? So we have 2 divided by 5. Same way as saying 2 divided by 5. If you want to divide this, 2 goes inside the division bracket, right? Can 5 go into 2? No. So we have to drop a decimal, bring the decimal up, extend this out, and then we drop a 0. And then you ask yourself, can 5 go into 20? How many times? How many times?
4.
4 times. 4 times 5 gives me 20. That terminates, and I'm going to have 0.4, 0.4. So it's actually going to be 0.4 or 0.4. Right now, I'll just write 0.4. Yes?
Why can't you just do 5 divided by 2?
Because it's not 5 divided by 2, it's 2 divided by 5.
Oh, okay.
What we're saying is that the number 2, because the way it's written from left to right, the number 2 is being divided by 5. The reason I wrote this one out flat, I wrote this one stacked, so you can see the different ways this problem might present itself. That's division. That's 9.6 being divided by 2.4. This is 2, comes first as we go left to right. 2 divided by 5. So make sure when you do that, realize that 2 divided by 5 is the same as 2/5, or 2 divided by 5, and that's going to give us 0.4. Okay? All right. So back to this now. 0.4. And then, Miss Thomas. Miss Thomas. What am I doing with those exponents? Subtracting them. So we're going to do 10. What are my exponents? 9 and 5. So what am I writing first? 9 or 5? 9, yeah. We work left to right. 9 first. 9 minus 5. What's that going to give you? 10 to the 4th. Okay, good. Let's go to Miguel. Miguel Mota. We're going to write out what she gave us. She gave us, Rachel gave us 0.4 times 10 to the 4th. Am I going to walk away and leave that answer there? No, I can't because it's not good scientific notation. My coefficient is less than 1. Can't do that. So what am I going to do?
You're going to move the decimal point to the right.
I'm going to move the decimal how many times?
1.
1 time to the right. Boom! And that's going to give me 4. Okay, that works. 4 times 10. But keep in mind, if I move my decimal, I must change my exponent. Lucas, my coefficient got larger. So my exponent gets smaller. What am I subtracting, Lucas, from my exponent? 1, because I moved the exponent 1 time, so I do 4 minus 1, that's going to be 10 to the what power?
3.
Third power. Always make sure you write your answer in correct scientific notation. Keep in mind that if you're changing your coefficient, you're going to be changing your exponent. Keep in mind that inverse relationship. Questions? Questions? No questions? We good? We just like, nah, man. I got it. I got this. You're going to see. I got it. You sure? Okay. 4, 3, 2, y 1. Okay. So now we're going to deal with addition and subtraction. When we add or subtract in scientific notation, there's something that we have to do first. Before we can do any type of operation with addition or subtraction in scientific notation, the first thing that we have to do is we have to line up the exponents. What does that mean? Perdomo, eyes over here, please. That means that we look at the two exponents and we ask ourselves, self, which one of these decimals, not decimals, exponents, which one of these exponents is smaller? Which one's smaller? Shimon, which one's smaller, 3 or 4? It's like 3. 3 smaller. 3 smaller than 4, right? Right? Shimon, 3 smaller than 4, right? Okay, so we go to 3. We need to do whatever we have to. Whatever we have to add to 3 to turn it into 4, that's what we're going to do. What can we add to 3 to make it 4? Anybody? Anybody? 1. So what we're going to do is we're going to add 1 to 3. If we add 1 to 3, that means that the exponent got larger. So what has to happen to this coefficient? What has to happen? Anybody? It gets smaller. If the exponent gets larger, the coefficient must get smaller. We're going to move this 1 time. And notice that this is before we do anything. We're not adding, we're not subtracting, we're not doing anything. Before you do anything, with addition, later on subtraction, you must line up the exponents first. If that's a 3 and that's a 4, they both have to be 4s. Identify the smaller one, do whatever you have to do to make that smaller one equal the larger one. So we move the decimal 1 spot to the left because we added 1 to the exponent. What if we had moved the decimal 2 spots to the left? What would we have added to the exponent? What? It become 5. We don't want it to be 5. We want it to be 4. I just want you to know that whenever we add 1 to the exponent, that means that we're going to be moving it 1 spot to the left. So this is going to be a 4. This is going to be a 4. And then before you start working, rewrite your problem. 0.314 times 10 to the 4th, parentheses, plus, yes, always write the parentheses, plus 4.25 times 10 to the 4th. Do I have the same exponent now, yes or no?
Yes.
Yes. And that means that now I can go ahead and solve this problem. That's actually probably the trickiest part of addition or subtraction, just lining up the exponents. Once you line it up, it's simple addition with decimals. As long as you remember how to add with decimals, then it's going to be a very easy task. If you forget, I will show you how we add with decimals. Everyone have this written in?
Yes.
No.
Okay, so we're going to take, no? Oh, let me take it. There, now it's written in. Okay. So, first thing we did, line up the exponents. Now, you're just adding the coefficients together. Let's go to Corey. What are my coefficients?
Your coefficients are 0.214 and 4.35.
So we're going to take 0.314. We're going to add that to 4.25. Remember that when you add decimals together, you're going to line up the decimal values and you add as you would any other number. And it's going to look just like this. I'll go back 0.314 and then we had 4.25.
Oh.
What goes here? 0. Doesn't matter which number you put on the top or the bottom, you're just adding them together. 4 plus 0 is 4. 1 plus 5 is 6. 3 plus 2 is 5. Bring down your decimal, and then just bring down your 4. And we'll get our new coefficient, which is going to be 4.564. So this becomes 4.564. 4. Is that a good coefficient, yes or no?
Yes.
Yes. And the good thing is, because we're doing addition, we've already done our work with the exponents. There's nothing left to do except write your answer. I write my coefficient because it's good, 4.564 times 10. I already did my work with the exponents. Don't need to do anything else. Times 10 to the 4th. That is it, man.
That's easy.
The trickiest part of this is just lining up the exponents. All right. Alan, I want you to look at my 2 exponents here. All right? We're going to be doing addition. So when we do addition, we have to line up the exponents. You got me? Which one of those exponents is smaller? 1. What can I add to 1 to make it equal 3? 2. So we're going to add 2. If the exponent gets larger, the coefficient must get smaller. Good. Which way are you moving the decimal?
To the left.
To the left. How many times?
Once.
What did you add to 1? 2. That's going to let you know how many times you moved the decimal. See how we added 1 up here, so we moved the decimal 1 time, right? Back here, we added 1 to it, so we moved the decimal once. Here, we're going to add 2, so we're going to move the decimal twice. Which way did you say?
To the left.
The left. 1, 2. What goes in the gap?
0.
0. And then just rewrite your problem. And you're going to have 0.082 times 10 to the third now, plus 5.64 times 10 to the third. Oh, by the way, in case you're wondering here, that's what she said. 1 is a smaller exponent, so we add 2 for it to equal 3. Now that we have my exponents lined up, Fiamma, once I have my exponents lined up, what is the next step? What do I do? What's it telling you to do?
To add the coefficient.
Add the coefficients. And what are my coefficients?
Point 0. Wouldn't that just be 0.82?
No, if it was 0.82. Here's the difference. If we have 0.082, it stays like that. But if you have 0.82, then yeah, you could write that as 0.82. Notice that here, the 0 is to the left of the decimal. Here, the 0 is to the right. If you were to take away the 0, you have now made this number a lot bigger than it was. So be careful. So it's 0.082 plus 5.64. Anybody know what that equals? Yeah.
I got 5.722.
5.722 is correct. It becomes 5.722. Is that a good coefficient?
Yes.
Why?
Because it's
Equal or
Greater than or equal to
1.
and it's less than 10. All right, so it's a good coefficient.
Another one?
Yeah, I've already done my work.
Add 5.
I've already done my work with the exponents. Now I just write out my answer. 5.722 times 10 times 10 to the third. Good. Good coefficient, perfect scientific notation, and we're done. Good job, good job, good job. Yeah. All right, subtraction. We're going to go to Matthew Slantana. Sabro. In Miami, Matthew Slantana takes on the entire Doom Squad in a no-holds-barred cage match. Watch it on pay-per-view. Yes, that's what happens in here. All right. First thing we need to do, just like addition, Matthew, just like addition, when we do subtraction, we must line up the exponents. Which one of those exponents is smaller?
2.
2. So, ask yourself a question, what can I do to 2 turn it into 4?
Oh, we're still adding it then.
Yeah, you're still gonna.
You couldn't just turn the 4 into a 2.
You could. I always uniformly teach it the same way, because that way it's easy to remember. I have 2 exponents, that's smaller, I can add to this, and I know that I'm always moving my decimal to the left, right? If you want to subtract that, that's fine. I teach it one specific way because it's easier to remember. But if you want to go off on that, as long as you remember how to do it, you would go to the right. So you're with me? We're going to add 2. You with me?
Yeah.
If my exponent gets larger, my coefficient must get smaller. So which way are you moving it?
To the left.
To the left, how many times?
Twice.
Twice now. 1, 2. What goes in the gap?
0.
0. Alright, so we'll write out this problem again. Now it's going to be 3.4 times 10 to the 4th minus 0.055 times 10 to the 4th. We've lined up the exponents. Now we can go ahead and subtract. This is subtraction. We're going to subtract the coefficients. But Dyson, what are my coefficients?
Coefficients are 3.4 and 0.055.
Okay, let's subtract them. 3.4 minus 0.055. But Dyson, you know what that is?
No.
Anybody want to help her out? Anybody know what it is? Anybody? I got a ticket right here. Lucas, what is it?
It is 3.345.
Bam! He's done. 3.345. When I do the subtraction, that's what I'm going to get. 3.345. Then you ask yourself before you move on, is that right there, is it a good coefficient? Yes or no?
Yeah.
Yes, it is. Now I can just write my answer out in perfect scientific notation. 3.345. Drew, times what? Times 10 to the power of 4. Thank you, Drew. Thank you very much. Thank you all for coming. Okay? All right. Jennifer's hoping I forgot her. I didn't forget. I'm coming right back to you. All right. We got a whole bunch of exponents here. We need to make them all the same. The easiest way to do that is to increase them all until we get to the larger exponent. All right? So, we look at 4. What can I do to 4 to make it 5?
I do plus 1.
I do plus 1, plus 1. What can I do to 3 to make it 2?
Plus 2.
And you realize the rest of that's 3 to make it 2? Yeah. What can I do to 3 to make it 5? I good? I add 2. 1, 2. All right, now we got to go. We got to fix all of our coefficients. This is not going to change because I didn't do anything here. So I'm just going to write that out as 6 times 10 to the 5th minus. Okay. Jennifer. I increase this by 1. If the exponent gets larger, the coefficient must get smaller. Decimals here because that's a whole number. We move it which way? To the left. How many times? You sure? You sure?
Yeah.
100%?
Yeah.
Okay, she's right. So we move it right there. We're going to write 0.4 times 10 to the what, Jennifer?
5th.
Yeah, good. Subtraction. All right. This got larger. This gets
Smaller.
smaller. It's a whole number. Drop the decimal there. Which way are you moving it?
To the left.
How many times?
Twice.
4 times? 6 times?
Twice.
19 times?
Twice.
Twice. Okay, good. 1, 2. What goes in the gap?
0.
Don't ever forget your gap. You forget your gap, it's going to be wrong. Got to have that 0 there. 0.3 and 0.03, totally different numbers. Now we write up parentheses. I'm going to have 0.03 times 10 to the what, Jennifer?
5th.
Good job. Now we got it written out. And I can do some work. Yes.
I was going to say if you want to subtract the answer.
What happened?
I was going to say the answer to the subtraction.
All right. You have it. I'll come and I will let you tell me. First tell me what we're going to be subtracting. What are we going to be subtracting here today?
We're going to subtract 0.03.
Hold on. What's the first number?
6.
6 minus
0.4.
0.4 minus
0.03.
0.03. I do declare that is the correct sequence. Now, when you perform this subtraction, what you gonna get?
5.63.
5.63. And then we got a different answer to this here question. Lucas, what you got?
I got 5.57.
5.57
5.6.
is correct. Amen. Yes. Woo! 5.57. We got it. All right. Is that a good coefficient?
Yeah.
Yes.
Yes, it is. Is that a good coefficient? Is it? Is it?
Yeah.
Yep. Is it? Yes, it is. We're going to write out a final answer in correct scientific notation. And I'm going to ask you! No, Lucas, I'm happy to be your card. What's my answer in scientific notation?
That's 5.57 times 10 to the power of 5.
5.57 times 10 to the power of 5! 5.57 to the power times 10 to the power of 5. Questions here? Question here.
No.
You sure?
Yes.
Okay. 4, 3, 2, 1. Yes! We saved the easiest thing for last. There's no math here. There's absolutely no math involved here. When we are transferring numbers from scientific to calculator notation, or calculator notation to scientific notation, it's a very simple process. So far we've been writing things in scientific notation, such as 8.132 times 10 to the fifth. When we're going to transfer this to calculator notation, here's what we do. We simply get rid of the times 10, that's gone, and we replace it. Are you writing it in? Whiteboard underneath, erase it, erase your whiteboard, put it underneath. We get rid of the times 10, and we'll replace it with a capital E. I'm sure if you've ever looked at a calculator and you have a number that's way too big, it looks like an E, you get like 8.E something times 10 to the fourth or something, that's what it means. It's not, everyone thinks it means error, it actually means that it's converting it to calculator notation for you, which is just a way of writing those big numbers in a calculator in a much smaller form. So we'll replace the times 10 with an E, and this would become 8.132. This is gone, an E, and a 5, and that's it.
Wow.
And we don't write a little 5. The 5 is going to be the exact same size as the rest of the numbers. I know, this is super simple.
What the heck?
That's all it is, man. Okay, Connor, we have 9 point, no, this is simple. This is the easiest part. I saved it for last. 9.4 times 10 to the fifth. We're writing that in calculator notation. Tell me what am I going to write?
9.4
Uh-huh,
E
uh-huh.
to the fifth, and the 5.
E and a 5, yes, a regular size 5. 9.4 E 5. That's it. Simple.
What?
Simple. Simplest thing. I know, it's one of those things that is, no, it's not. There's no math here. This is the simple part. Let's look at another one. I'll give you a ticket in a second. Let's go to Adriana.
Yes.
Adriana, how would we write that in calculation?
3.15 E -3.
Good, 3.15. This is the easiest thing that you'll see.
Are you sure you need to make a negative into a positive?
3.15 E -3. No, that's it. Just write it as. The only thing is, times 10 disappears. It's replaced with a capital E. It's just that simple. All right, but what if we have calculator notation? We want to write it in standard. Just reverse the process. Somebody haven't bugged yet. Miss Vega. No, it was you actually. Sorry. Hold on. Do that. Connor, that's for you. Make it rain. All right, Miss Vega. We just want to write this in scientific. So just reverse the process. Get rid of the E. Replace it with a what?
Take out the E.
Uh-huh.
You put 10 to the fifth.
4.2. Don't forget the multiplication. Times 10 to the fifth. Okay? Good job. Gosh. 4 quick problems on the whiteboard and we're done. Everyone have this? Just make sure. Rapid fire! Let's go! Let's go to. Hold on. No, this is not a whiteboard. This is not a whiteboard. You would see the 4, 3, 2, 1 first. 4 quick problems. We got 4 quick problems to make sure. Alicia!
I finished. It's not a way.
Alicia! It's not a whiteboard. Alicia! Calc notation. What's this going to be?
1.75.
Capital E. 4. Good job. Let's go to Fiamma. Fiamma. What is that in calc notation?
3.12 capital E -5.
Good. Ali. What is this in scientific notation?
9.4 times 10 to the 5.
Beautiful job. And Dylan, greatest rapper of all time. What is that? Scientific notation.
3.6 times 10 to the negative 3.
3.6 times 10 to the negative third. What? Yeah, you're right. Okay. All right. Any questions? Easiest thing for last. All right. We're going to finish up now. This is your final whiteboard. When you're done with this whiteboard, you erase everything, put it away. We're starting homework. Okay. Okay.
If somebody put